Hey guys, my name is NPizzo9. I'm a senior at FAU High School in Boca Raton, Florida, and I was recently named a 2020 Regeneron International Science and Engineering Fair finalist. Unfortunately, the fair got canceled this year due to the coronavirus pandemic, but I still want to tell you a little bit about my project, its implications, and the benefits that Science Fair has had on my life. So my project involved detection methods for citrus greening disease in South Florida. So all plants, as you may know, have different kinds of vascular tissue that help them grow and sustain life. So in plants, they have xylem and phloem, which help transport water and nutrients, similar to how blood vessels and arteries in humans transport blood. It's important that these vessels remain unblocked so that the water and nutrients can constantly travel through them. In citrus greening disease, it's a bacterial infection that is similar to malaria in humans. It's transmitted by the Asian citrus psyllid, this really nasty bug that forms a parasitic relationship with the trees. So it gains the benefit of getting nutritious sap from the trees, but it also injects this really horrible bacterial fluid inside of the leaves. Over time, this causes bacterial clogging, and it eventually causes a very slow death for the trees. So my goal through this project was to determine a way to have a rapid detection method using different kinds of technologies. So one, I used scanning electron microscopy, which is a really high magnification, high resolution technique that allowed me to examine inside of the leaf. But a scanning electron microscope can go up to 60,000 times. That's a lot of magnification. So using this, I was able to actually visualize the bacteria that was clogging the phloem in these leaves. The second technique that I used was qPCR. qPCR it allowed me to magnify the DNA that was inside of the leaves. And why was this beneficial? So by analyzing the DNA inside of these leaves, I could determine whether the bacterial DNA had incorporated itself inside of the citrus DNA. So using the SEM for the scanning electron microscopy and the qPCR in combination together proved to be a really helpful detection combination. My inspiration for the citrus greening disease project comes from the fact that I've been living in Florida my entire life. I wanted to tackle a problem that hits close to home and I could have a really direct impact on. I teamed up with a professor and researcher at Florida Atlantic University who had the technology that could bring my project to life. Like a lot of other students, I started Science Fair early in my elementary school career and in through middle school. But my more advanced projects didn't start developing until I was in high school, and I had the knowledge and resources to actually come up with advanced projects. So even if you haven't done Science Fair in the past, high school is a great place to develop those ideas. Science Fair has allowed me to develop my passion for learning and research and given me a platform to share my ideas. It was a lot of work getting to where I am today, but it taught me so many valuable things, like time management, hard work, and getting to contact research professionals in the field. My advice to you is to never stop learning about the world. Be an active learner and a critical thinker. Try and think of a small idea that you can develop into a larger project, and do this through Science Fair. It can really take you far in competition and bring you a lot of reward. Ask for help if you need it. I'm sure your science teachers and faculty are willing to help you if you just ask for it. But whatever you choose to do, make sure you're passionate about it. This will help you not only in Science Fair, but also in life. Bye guys.